So talking about multiplexers, you have one is just MUX multiplexer, and another you have DE-multiplexer. So what you have in multiplexer is many input but only one output. In DE-MUX it's reverse case, only one input and many outputs. So usually the basic thing for MUX is, so you know we have to draw a box. This is your combinational circuit where you will write inside MUX. So you will be having 2 power n is to 1 MUX. Okay, so this n defines the number of like inputs. Suppose you have only one, n is 1, you will have only one select line and one 2 power 1 is 2, right? So 2 inputs. So this is your select line, that will be S0, and this will be your input D0 and D1, one output, that is your Y. Suppose n is 2, so you will have 2 select lines, and here you will have 4 inputs. So D0, D1, D2, D3, like that. And if n is 3, then you have 3 select lines, this S0, S1, S2, like that, so on until D0 to D7 you will be having. So this is your basic thing. Suppose let us take an example for this. 2 is to 1 MUX. So you will have one select line, that is S0, 2 inputs D0, D1, and one output, that is Y. So what will be your truth table for this? So this is S0, and here you will be having Y. So S0 is like a select line. If select line, like it depends upon your select line itself, like what output you will get. If S0 is 0, you will get D0. If S0 is 1, you will get D1 as your output. So that's how we write our truth table. So if you want to write the expression for this, so y is equals to y1 is equals to, so you can write like S0 D0 and y, or else you can simply write y is equals to this plus S0 D1. Why here bar is there? Because it is 0, right? If it is 0, you will get D0. So S0 bar D0 and S0 S0, there we don't have bar because it is 1, then D1. So your equation for this is this. Suppose they might ask you to write a Verilog program, so you just have to remember this equation, and you can simply write the third behavioral model Verilog HDL program for this, and you will get marks for that also. So only for 2:1 MUX, you just have to remember this, and how to put this logic diagram. So see here, we have drawn the logic diagram also. So for S0 and S0 you will be having. So let me draw here itself again. So only for S0 you will have lines like this. Okay, this one line. So this is for S0, this is S0 bar. So you will have one D0, D1. So first what we had, S0 bar into D0, right? Then D1 with S0, I mean not S0 means S0. So now what we do here, see here, we have to add this 2 AND gate in output of this 2 AND gate with one OR gate. Like the definition says, we need only one output. So in first lecture I was talking about this itself. So there we won't be making it single output. Only in multiplexer we will be changing it into one single output. So whatever equations you get, no matter what. So this was your S0 bar D0 and this was your S0 D1. So both the thing will be added here. So y equals to the equation which I wrote. So that matches this diagram. So that's how you draw this first with select and proper, everything I mentioned. Draw the truth table. From the truth table, get the equation. From the equation, draw this logic diagram. Here you don't have to draw the K map, but further you will have some tables which you have to draw. So moving on, so we have here 4:1 DE-MUX over here. So let me again draw that here. So it is 4:1 with nothing but 2 power 2, right? 4:1, you have to write MUX mentioned like that. Then you will have 2 select lines, that will be your S0 here and S1 here. Only one output, that is your Y, and you will have 4 inputs, because 4, right? So that you can name it as D0, D1, D2, D3. Now what will be the, see, so your output side you will have Y, so that it should be D0, D1, D2 and D3. Okay, so you have here S1 here, S0 here. Okay, so 0 0 0 1 1 0 1 1. So that's how you draw the logic diagram. Just put S0 here. What are the select lines are there? That will be here in input side. S0, S1 you have to draw, right? 0, 0, normal basic like truth table how you have to draw, and one by one just write the outputs. It's simple as it is. Now let me erase this diagram. Now you see here, for we will have now equation, right? So we need 4 equations here. So simple thing, what you have to do, write S0, S1, and then you write D0, again S0, S1, D1, S0, S1, D2, S0, S1, D3, here plus, here plus, the remaining thing I have written here, here plus. So now see here, then see the table. First both are bar, so S0 bar, S1 bar. Second only S0 is bar. For third, S1 is bar. Fourth, no bar. So this is your equation. Now for this equation you have to draw the logic diagram. So you just see equation is here. Now I will draw the logic diagram same way. So this is my S0 and this is for S0 bar. So I need one more line for S1. So this is my S1, this is S1 bar. So now I will write D0, D1, D2 and D3. So now it will be visible for you. Just try to like write down this equation. So or else let me just write it here itself. So what was the first one? So we have this bar, and one this. Okay. So this is my D0. Then what you have, only S0 bar is there. Okay. Remember from where you are taking the line. Then here S1, then D1. So this is my D1. Then what do I have? S0 and S1 bar I have. Then D2. This is my D2. Now at the last we just have S1, S0, S1, then D3. Now what I have to do? Add all these 4 together in one OR. Okay. Here y equals to, then write all the equation everywhere like this. So this is how you draw the logic diagram for 4:1 mux. Similarly, you have to do for 8:1 mux. I'll just show you how to, like from the table, how to write the equation in a simple way. Now see here, for 8:1 mux. So it is 2 power 3:1, 8:1 mux. How many select lines? Okay, we'll have 3 because n is 3, right? S0, S1, S2. Output always 1 itself. We'll have 5, 6, 7, 8. So here D0. So I'll just write like this, and D7. From D0 to D7. So how to put the truth table? Let me show you in the book itself. So as you can see here. So here you have 8:1 mux, and here I have drawn the diagram over here. So 2:3:1 y. So S0, S1, S2. So you can see the truth table here, 3 variable truth table, just like this. Draw normally, and then one by one just write D0, D1, D2, D3, D4, D5 up to so on D7. Now see here, to write the equation, how to write. So you will be having only one output. So y equals to. So here first thing what you have to do. So just write S0, S1, S2, okay, and D0, S0, S1, S2, then you write D1. So similarly S0, S1, S2, S0, S1, S2. I am writing down because I don't have space. In even you can do like this if you want, or else D1, D2, D3, D4, here D5, D6, S0, S1, S2, D3, S0, S1, S2, D6, and here we will have D7. I mean 1, 0, 1, 2, 3. So here 4, 5, S1, S2, D7, plus, 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 plus. Now then according to the diagram, now we can see easily, and then put the bars. So for first all 3, second one this 2, in the third we have here and here, okay, and in the fourth only on this. So from here this 4, this first thing won't be having. So 0 here, here, some here, then this will have only here, here we have only here, here nothing will be there, that's it. So that's how you write. Now what you have to do, see the diagram over here. See, in book the numbers are like misplaced here, so just ignore this. See this equation, this is correct. Okay, so now what you have to do, see this equation through logic diagram over here. So that's how you do. So here all are bar d naught, then here d1, how you took one by one you have to take each line. So d0, d1, d2, d3 like that. For all the things are then matched from this all the AND gates are then connected to this OR gate. From OR gate just extend one line and write y. So that's how you write your 8:1 mux. So this is the introduction for 2:1, 4:1, 8:1 mux. Now let us solve some questions. So you can see here that there is a question f of a comma b comma c is equals to summation m of 1 3 5 6. Solve this using 4:1 mux. Now what you have to do is, first thing you have to draw a table. Okay, since it is 4:1 mux, we will have three only two variables over here. So draw a diagram like this. So what you have to do, just write 1 2 3 0 1 2 3 4 5 6 7. Remember to start from 0, don't start from 1. So then what you have to write, how many inputs are there, d0, d1, d2, d3. Okay, because 2 bar same. So here just take a bar here and here a. So usually 0 and 1, right? So like that it is. Then now what you have to do, now what they gave, summation m of 1 3 5 6. So where is 1, circle, 3 circle, 5 circle, 6 circle. So now see here, if now you have to write d0 like this. Okay, now what you have to do, just see here, if both you have to come like this. If these two are empty, it will be 0. If these two are circle, it will be 1. Okay, both are not circle, it is 0. If both are circle, up and down, it's 1. Only down it is circle, then only a will come here, because a is here. Only up is circle, then a bar will come like this. Okay, this is the way you draw the table first. From this table, what you do now, you draw the this mux table, 4:1 mux, and you will have okay, now you will have here two select lines and one output. Now here you will have inputs here, like here it is here d0 d1, but what you have to do, you have to take these are your inputs now. Okay, so here let me just erase this. I will draw this again here. Zero, 1, 2, 3, 4, 5, 6, 7. So 1, 5, this. So here 0, 1, here a bar. Okay, so now I will take a line like this. This is for a and a bar. Okay, a and a bar. Now you have here 0 and 1. Okay, so this is your for d0 and 1 is for your d1 and a for your d2, a bar for your d3. 4:1 mux, and you will have a select line. You can do like this also, S0 and S1. Okay, and your output 1 y. So that's how even here it is written. So here since we have three variables here S0 and S1, right? So you can name this as BC also. So it doesn't matter, like you can keep here, you can use A, B here, and you can write C also here. That's all your wish, your choice how to do that. After this, what you have to do, there is one theory part over here which you have to like write over here. Okay, so n comma variable, n is nothing but your variable, which is equals to 3. So n is your variable. Okay, n comma variable, that is your 3. So now again next line is n minus 1 is your select lines. So what I used to say, like how many variables you have, the so here we have, just a second, I guess okay, so number of variables is nothing but your n here. So I thought it's not like that. So 2 power 2, right? So variables which they gave here a comma b comma c, according to that we will be getting this. So here how many variables do you have? That is that we say for n comma variable is equals to 3. Okay. So now variables are 3. We see a, b, c. So now n minus 1 will be your input lines is equals to 3 minus 1, that is 2 select lines. Okay. Select line. Just ignore the handwriting if you understand, that's important. Select line. Now how many inputs you have here? See, 2 power n minus 1 is 2 mux is equals to 2 power 2 is to 1, which is equals to 4 is to 1 mux. So at the initial I say directly 2 is to n, right? So according to that it is all the same, but here you have to write variable is equals to here n plus 1 is equals to variable, that is not 3 like that. So it will change. So according to this definitions, your mux will n 2 power n minus 1 is to 1 mux. So as you saw, you had 3. So 2 power 3 minus 1 is nothing but 2 square, which is equals to 4 is to 1 mux, and those many inputs you will be having. Okay, input lines. So 2 power n minus 1 is equals to 2 power 2 is equals to 4 input lines, and you have to mention those them as D0, D1, D2 and D3. First write this. After writing this, draw this table and then you go for this diagram. Okay. So that's how you solve this question. Let us solve another question now. So what they have given in the question, f of x y z. So again x y z, f of x y z. So again here 3 summation m 1 2 6 7. Okay. So now let us write. So n comma variable, how many variable do we have? 3. So n minus 1 select lines is equals to 2 select line. Okay. Now how many data input? So we will have 2 power n minus 1, nothing, there is nothing but 4. We have to mention like this. I am writing shortcut, so just write here 2 power n is 1, substitute the value of n, 2 power 3 is to 1, which is nothing but 2 power 2, then you write 4 data input, then you have to write they are D0, D1, D2 and D3. Now what you have to do, they make this table. Instead of truth table you are doing this, and write 0, 1, 2, 3, 4, 5, 6, 7, D0, D1, D2, D3. Here A bar will be there, here A will be there. Now for 1, for 6, for 7 and for 2. If both the up and down it's not a circle, that is 0, only up is circle. So what is there in that up? A bar. Both are circled, one only down, so here only A. So now how this your diagram will come. So you will have 2 select lines. Let me write in here itself shortly. So S0 here S1, 1 output, that is your Y. So D0, D1, D2, D3. So your D2 is 1 and your D0 is 0. So D1 is your A bar. Okay. And D3 is your A. Okay, I mean yeah, D3 is your A. So this is how you draw the diagram. First write this, draw the table and make this diagram. That's how you solve your equation or whatever the question they are given, and you will get the complete marks for this. Let us move on for 8 is to 1 marks, and we have one more topic and that will finish your marks. So similarly they gave f of a comma, now I will show you in the book itself. So it's easy and neat here and you can understand easily. And what mistake I did here, instead of x y z I took a b c again, so that's a mistake. Don't change the variables, whatever variable they gave you have to do in that itself. So by mistake I took a bar and here b c I gave, so don't do that mistake. Now see here f of a comma b comma c comma d summation m 0 1 3 4 8 9 15. So for 4 variables you will be having 16 box totally. So what you have to do, 7 7 like this. So write d0 to d7 and 0 1 2 3 to up to 15. So total 16 should be there. So we are starting from 0, it will end from till 15. So whatever number, just circle it, up a bar, down a. So both the circles are there. So that's why 1 1, both are empty, 0, only above 1 is there. So a bar, both are empty, 0, here also 0, and down only a. So first you have to write this. So n comma variable equals to 4, n minus 1 is equals to 4 minus 1, which is equals to 3 select lines, 2 power n minus 1 2 mux, 2 power 3 2 mux, that is nothing but 8 is to 1 mux. So inside you have to write 8 is 1 mux, 8 data input lines, that which is nothing but d0 to d7 you have to write one by one. Then just draw this A and this for A bar. So wherever only A and A bar is there, right, there you have to take lines from here. So remaining you can simply write 1 1 0 and 0 0 like that, and from there you can give lines like that. Select lines you will be having 3 B C D, you can give those names B C D, and your output is F. So in question they are given F, so you have to put F. If they had given Y, you will have to put Y. So that's how you solve your what is this 8:1 DE-MUX equation. So now they might ask you like they will give, so see here, instead of numbers they have given you f of a b c d. 4 variables are there, but here they have given only 3 variables this equation. So how to solve this is the same way like we did in SOP, where the missing term we have to multiply that with that missing term and its complement. So into that suppose here c is missing, so into c plus c bar, like that you have to multiply completely. You can see here which I have done, and then give the, if it is if the term is having bar, write 0 below it, and make sure you write it in the arranged format. So here a b c d, don't jumble, okay, it should be a b c d itself, don't mess. So suppose if you multiply c here, don't make it like a b d c and all like that, that's wrong. So don't do that mistake, just see here, pause and see if you want, and then you will get these numbers from the equation 1 3 4 5 6 11 15. According to that, put the lines, write the theory part, just 4 lines always you will be having, and then the diagram. So that's how you do. And sometimes they will give POS also, right, pi m also. If they give pi m, what you have to do, you have to remove the summation m of that. As you can see here, you have to remove the summation m of that. Now after removing the summation m, just draw the table. Here I did not write the theory part because I just skipped, because I know, right. So just write the theory part, same theory part only you will be having, nothing changed. So whatever you have here, this theory part same will come here. Just see wherever 0 a bar a, so you have more a terms here. I am only 0 and 1 time. So 0 1 last I have given, remaining all from this line I have given a. Even here if you see the same thing, it is solved here. Just pause and just see here if you want. So also this question they have asked us to solve using 2 4:1 mux. So here using 8:1 mux, also using 4:1 mux. Using 8:1 you can see here and pause. I will explain you how to do using 2 4:1 mux. So see here in this diagram, just draw 2 4:1 mux and divide the input lines. Here you will have D 4 0 1 2 3 and here 4 5 6 7. So you will be having this E over here. So for time being I don't know what this E is called, but it's like some connector, okay. So and you have here NOT gate here. So why the NOT gate is mentioned here? Suppose if E is like 0 na, so if it is 0, this won't work. So at that time this both won't work, this both E won't work. So if you want input from this 4, so this part won't work, only this will work. And if it is 1, so suppose this is 1, this will work. Now if it is going here na, so it will become 1. From here if it is going again, so now you see here, if it is goes like that, so first it will be, both will be 0, right. So see here, this will be 0 here. So if it goes like this, it becomes 1. Then this becomes 1. So when this becomes 1, so this becomes 0. So which thing is 0, that won't be working. So first everything is same. Just one thing what you have to do, split this 8:1 mux into 2 blocks, and the 2 blocks are 4:1 mux. Now between these two you will connect it with the select line itself, and here select lines will come. Now see here, in 4:1 you will be having 3 select lines, but here only 2 select lines, okay. Just remember that. So W is there, Y Z is here. Here X we are not mentioning or writing that X here. So how you will get? So see here, just W and W bar. So same thing, same table itself you will be having for this. So wherever you have W and all, you give from this line. Where you have 0 1, just write 1 like this and pass. So this NOT gate is very important. Why? Because NOT gate na, it changes, right. So it gives a complement. So if this is 1, it makes this as 0, such that this block won't work, and if this is 1, that it will make this as 0, such that this won't work. And whatever output you get, both are added in through OR gate and gives a single output. So this is how you implement for using 2 4:1 mux, 1 8:1 mux. So this is simple. Just try to change the equation. For every equation you can do like this. So now this completes your mux. Let us go to the DE-MUX. So moving on to the DE-MUX, as you see, I won't be using or writing you anything here. I will just show you from this notes itself. So here you have 1 is to 2 power n what to say outputs. So, here you will have only one input, that is your D as your input, and you will be having only one output. So, see here. So, 1 is to 2 power n. Suppose if you take for 2 power so suppose your 2 is here. So, for 2 is to 1 mux I have not written here. So, let me write for 2 is to 1 mux itself. I mean 1 is to 2 D-MUX, sorry. For 1 is to 2 D-MUX, your 1 select line will be S naught, and you will be having 4 this Y0, Y1, Y2, Y3, and this should be D itself, I think. So, that yeah, D in. So, this will be your D in. Okay. So, what will be the here you will be having only 2, by mistake I wrote 4, that will be your Y0, Y1. So, Y naught, sorry, this is Y1, this is Y naught, and this is your S naught. So, if it will be either 0 or 1. So, okay, so if it is 0, this will have and this will have D in. Okay, the remaining thing will be 0, 0. Did you understand? So, this is how it is written. Okay. So, let me write again. So, S naught, it will be either 0 or 1. Then you will have one output, that is Y naught, one other output Y1. If it is 0, this will have D1. So, first write like this, D in crossly. The remaining all are 0 you have to put. Similarly, how we do for 1 is to 4. So, you will have here extra. Okay. So, Y1, Y2, Y3. You have one more input line, that is your S1. Okay. S. Okay. So, now how you will be having? So, your S naught and S1. Okay. Then you will have Y0, Y1, Y2 and Y3. So, first write here 0, 0, 0, 1, 1, 0, 1, 1. Then what you have to do? D in, you write cross like this, D in, D in, D in. So, remaining you have to fill with 0, 0, 0, 0, here 0, here 0, here 0, here 0, here 0, here 0. Now, coming to this, you will have different equations for this. So, let me try to write here. So, you have Y naught is equals to, now you see here, S naught, S1, this 2 bar will be there, and D in. Okay. So, Y1 will be equal to, see, S naught bar S1 D in. So, just let me erase this. So, let me show you how it will be same. So, S naught S1, S naught S1, here D in will be there, here D in will be there. So, it is like, see, 0, 0, 0, 1, 1, 0, 1, 1. So, wherever 0 comes, your bar will be there. If there is no 0, there won't be a bar. This is Y1, Y2 and Y3. This is how you write the equation for D-MUX. You will have 4 outputs. Input is only 1, that is D in, but you will have 4 outputs. So, let us see the in the book here, the same way I have written here, S1, S0, 0, 0 like that, and Y0, Y1, Y2, Y3. Same thing you will get here. So, see, I wrote S0 and S1 like this. So, you can write like this also, S0 and S1. But the bar and all how you write, that is the same as this. So, you can see here, for both bar is there, only for first bar is there, only for second here bar will come, only for here like that, no bar. So, you have to see the notes and then go through the notes and write. So, moving on, we have here 8 is to 1 D-MUX. Okay. So, first let me explain this part itself. So, you have 1 is to 8 D-MUX, 8 outputs, 1 input, 3 select lines. How will be the tables here? S2, S1, S0, S0, S1, S2, like this you write. Same, just write your normal truth table 0, 0, 0 for 3 variable, and then crossly you write D in, D in, D in. Remaining all are 0 for us. So, how the equation will be? Now, see here, just write SSS. So, S0, S1, S2, S0, S1, S2. So, like this 2, 1, 0, 2, 1, 0 like that, SSS. So, I will show how I wrote is like this. So, first I will write simply S 3 times. So, it is fast way. So, and it is very easy also to write 1, 2, 3, 4, 5, 6, 7, 8. So, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, like this, just write off. Then you write D in everywhere. Okay. I will simply put a double dash. Then what you have to do? See the table 0, 0, 0, then 0, 0, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0 1 1 1 0 1 1 1. So this is your equations. So y1, y0, y1, y2, y3, y4, y5, y6, y7. For all these 8 outputs, you have to draw this DE-MUX. Here you won't be connecting, okay? Each different. You want 8 outputs, you will have 8 distinct outputs. In multiplexer, you used to connect it. Suppose we solve these sums in multiplex, you used to connect this here. You can see here we are connecting all the outputs into one output, but in DE-MUX we won't be connecting like that. So I can see here in DE-MUX you won't connect anything like that. So everything is simple. Now you saw 1:4 and 1:8. Now again they ask you this using 1:4 DE-MUX. So nothing changes. What changes is the input will go here. That's it. 4 outputs you have, 4 here like this. Remaining everything is same. Nothing is different. So if you understand one, so remaining is easy. The one additional question, this question which mostly exam question which is asked is design full subtractor using demultiplexer. How to do this? For this you should be knowing the truth table for full subtractor. What is the truth table for full subtractor? We have here A, B, B in. So here we can use D in will be your input. So you have 3 select lines. So A, B, B in. These are all your select lines. 2 outputs. So one is difference and one is borrow. Okay. So here I will draw this separately in that whiteboard and show you how to give the connections. Just see here 0 0. This is 1 1 1 1 0 1 1 0 0 0 0 like that. So here now as you can see, I will draw this DE-MUX quite length so that you can see aram se. Okay. I will start from this edge because I need the right hand side. Okay. So see here we will be having y0, y1, y2, y3, y4, y5, y6, y7. So now how will you remove 8 outputs from this? Just see here wherever you have 0 we won't take lines from that. So for see here for difference, now I will keep this. Okay, just see here difference no, or else better I will write see here summation m. If I have to write here I will put like this. So wherever I have 1, so it is on 1 2 4 and 5, 1 2 1 2 4 7, correct, right? 1 2 5, sorry, 1 2 5 7. Okay, 0 1 2 4. Okay, 0 1 2 3 is not there, 4 is there, 5 6 then 7. This guy 1 2 4 7. And for borrow how I have, so it is not there, 0 1 2 3 and directly 7, 1 2 3 and 7. Now from this numbers we can put. So see here this is 1, right? So this goes from 2 we have, from 4 and from 7. So I have to make one OR gate here like this. So I will give this connection like this here like this, for here. This is my difference. For borrow again, now you cannot take from here. So for borrow what you have to do, you have to take line like this. Okay, I will make OR gate here. So for 7 you have to give connectors for the same line if it is repeating. So for 3 you have like this. Now you have to take a connector from 1 and give, you have to take a connector from 2 and give. It's a bit confusing from this line, but you understood how I gave the lines. So just remember from the table you will be having wherever 1 is there, right? So that represents your output lines. Now what you have to do again, so here, so you can write here borrow. So that's how you write implement your full subtractor using half subtractor. Here you will have select lines A, B, B in. Inside you have to write 1:8 DE-MUX you have to write, and then you have your D in as your single input, and that's how that finishes your DE-MUX concept. The remaining things are your coder and all. So you have other things also. You have your this kind of things. So you see your digital watches, right? Some in traffic signal, the how that those numbers are displayed, how to implement that, and you have your coder, decoder. So that will be explained in the next class. Thank you.